Good afternoon and welcome, everyone. Thanks for joining us this afternoon to talk about DynamoDB. We'll go over today why GE Aviation migrated to large Cassandra database to DynamoDB. But first, I want to give a shout out to my team back in Cincinnati and Bangalore. Thank them for all the hard work that they did to make this reality. It represents about 9 months of work, so we'll kind of go through what is there. And you can hopefully ask questions at the end. So Ari will be joining me a little bit later, but first let's go through some basics about what we're doing here. First, we're going to kind of go through a few things about who is GE Aviation, how we got from where we were to Dynamo, kind of that transition path amongst many technologies, and then what that looked like, how we implemented Dynamo, how it ended up saving us money and time and effort, and then really how it set us up for the future. What our plans are to take Dynamo into the next step for us as far as cloud usage within GE Aviation. And then after that, we'll discuss what were outcomes, lessons learned, things we need to do in the future, things we learned along the way, and then things that we're going to set up into the future for GE Aviation and what we do with this data. So who is GE Aviation? How many of you flew here today? Probably a lot of you. About 2/3 of you experienced GE Aviation engine usage. You used one of our primary services, being a jet engine, to fly here. So in the air today, there are approximately 2,200 aircraft with 300,000 people flying above the Earth to get to their destination. Every 2 seconds, we have an aircraft take off with GE power. This is a big deal to us. This is a big deal to our team, largely because we take it seriously to understand our customer, to understand how to make your experience as good as we can. We know flying isn't always the most convenient thing, and it's not always the greatest experience, but we want to do our part to make your experience as good as we can. So as we kind of look into the next slide, and maybe it'll turn. There it goes. That equates to about 60,000 installed engines in the air. It's a significant section of the fleet. Every operator that we have runs it. A customer from our perspective is an airline. It is an operator that takes one of our engines, bolts it onto a wing of a Boeing or an Airbus or a Comac or whatever airframe you have, and flies it from destination to destination. We have about 300 airlines that operate our engines, and while you are a customer in the end, we have to service the airline directly. We have to provide them with information, with data, with opportunities to serve you as well as we can. In question today is a set of data that we use on our customer portals. We affectionately call them portals, because they provide a significant amount of technology to our end user, to our airlines. They provide things like warranty, the ability to buy spare parts, the ability to log an inquiry, the ability to also look at their data, to look at the diagnostics about each engine that they have in the air. That data becomes part of their process, part of their way that they understand what their jets are doing in the air, what they're operating under, and whether one needs attention, whether we need to service an engine at the next stop, whether we need to replace a part, whether we need to take it off the wing and overhaul it. That data becomes very important to the operation of the engine, which eventually keeps you from experiencing a delay due to an engine not being in service. So this functionality is to ensure that we provide reliable and safe operation of all of our engines in the air. Now, key to that is my clicker. There we go. We need it to work too. So key to that is engine performance data. The engine data that we have, it gathers each and every flight. So as you're in the air, engines are operating, engines are flying, they're going through various phases of the cycle. You're taking off, you're cruising, you're landing. Those are generally the large cycles. When that engine's back on the ground, or even some cases while it's in the air, it's sending data back to us to look at, to evaluate, to analyze. A lot of what we will do is take that sensor data and transpose it, parse it into our databases, and determine, do we have an alert on an engine? Do we have a situation we need to take advantage of or take care of while it's on the ground? Now, customers can also log in and plot sensor data, as well as download this data from our customer portals. So this provides about 40 terabytes of data to the customer to have access to 24/7, to be able to log in, look at an engine, look at a collection of engines, and then download that data, or even download their entire data set, gigabytes of data at a time, to have on hand or to use in their own processes. So this is about 175 billion rows of essentially time series data from our engines as they're flying. We have a rough expectation when the customer portals are operational that we have about a 50 millisecond response on each query that we have through that process. Now, each service that runs to plot these data elements to extract this data, it may be multiple queries to present that because you can have multiple streams. So 50 milliseconds is about our threshold for when we start to experience problems downstream with the customer. Now, as we go forward, as IoT takes hold, as we see more and more sensors engineered into engines, as we see more and more capabilities brought into the engines to extract data, more frequent polling periods while the engine's in the air, that density of data continues to grow. We continue to have a need to grow this space. That 40 terabytes will be 60 to 80 terabytes really rapidly based on the current density of our latest engines that have gone into service. So as we look forward, we needed to evaluate where we're at, because we've had multiple technologies that Ari will take you through in a few minutes, but we have to plan for this growth. We have to continue to plan for additional volume onto this. So as an example, this is a time series plot from our customer websites. It's a little hard to read from back there, I understand, but essentially what the lines are certain sensors off of engines or a collection of engines. It's essentially plotting them against each other. Now, if you're a customer logging in, you're probably looking for trends, you're probably looking for anomalies in this data, you're looking for something that sticks out, or something that looks right. You're checking to make sure things are right in addition to when things aren't good. This is a primary functionality of our customer websites. If this goes down, if this is slow, if we get what we call a red box, which is essentially an error in the system, we hear about it really quickly. Our airlines are 24/7, they're flying around the globe, so none of us, especially Steve down here in the front row, doesn't like to get calls at 2 a.m. to fix it. So we want to make sure this works really well. The second piece of functionality that we have that is important with this data is some reporting that we provide. Now, this screen is not very user-friendly from your viewpoint out there, but what it does is it allows an airline to download bulk data. So you can take multiple ESNs, you can take a range of dates, you could download your entire history of sensor data from our website. Now, it provides you a link through email, and you download it there, so it's more of a batch process in the back end. But due to the size of these, you can imagine if I wanted to get 20 years of data for 100 engines, that's a significant amount of data. That's going to take some time to process and download. That has to finish, that has to be correct, that has to get to our customer. So we had experienced with previous technologies times where this simply wouldn't work. It would error out, it would time out. It was so much data that it couldn't actually be transferred, it couldn't operate within the technologies that we had chosen to operate it. So it was something that was extremely important to this process in how we go forward. So this is our customer. This is our customer's viewpoint. But in addition to all of this, there are internal tools that actually don't use this data yet, that are targets that we want to look at. You have internal processes that had grown up on other subsets of data, other technologies, and rather than risk the customer having a bad experience, we never brought them over onto the single technology because of this conflict of interest, if you will, between internal and serving our customer. So this also was a primary consideration as we went forward. Now, key to this story and what we're going to bring about is I need a clicker battery. There we go. Is, About 5 years ago, and Ari will give you a little bit of background, we started migrating to AWS as a GE Aviation entity. It was a lot of investment in really kind of migrating existing architectures, taking what we had architected in on-prem situation, lifting it to the cloud, doing it the same way. Now that got us some ability to manage scale. We were able to spin up servers faster. We were able to manage that cost a little better, kind of throw some levers that we hadn't really thought about in our on-prem situation. Our time to market or time to get apps up and running was faster. We were able to move quickly in those specific areas. We were also able to look at more technologies. We were able to kind of beta some things. It was a piece we didn't have before. We didn't have this ability to spin up a server, test out a new technology. We were very on-prem. Now, as we went through, we started to think about how do we go into cloud native? When do we go cloud native? We had done so much on-prem. We had talked about terms like cloud agnostic, and the ability to move from cloud to cloud had become very popular within GE Aviation. That this was really the first time, from a project perspective, that we had been given a little bit of freedom to look outside that box. And so we really wanted to understand more of the cloud native in this process, given this history as we migrate through. And I don't think it's an unusual story. I think a lot of people have gone through this similar migration, especially in the larger enterprise. So this was an important aspect to us as we went through this, was not just serve the data, but let's start to look beyond just databases. Let's look at cloud native technologies. Let's look at things that we can do better. So now with that, Arianna is going to introduce herself and take you through some of our architectures.
Thank you. Hello, hello, hello. My name is Arianna Lopez, and I'm a senior architect at GE Aviation. I've been with the business for about 7 years. For the last 5 years, I've been focused on creating the strategy on how our organization is going to use AWS. I've been a part of AWS since its inception at GE Aviation, so I'm very familiar with analyzing and evaluating legacy applications. I'm also very familiar with migration plans and then building automation using Chef and Jenkins to migrate those applications from on-prem all the way to AWS. So this leads me to portals. Corey explained what portals is, why it's important to our customer, and how it is used. Now it's time to go a step further and start looking at some of the technical details, in particular, what data storage we were using historically, and then how did we go to DynamoDB. There we go. So in 2005 and 2006, we were seeing a trend amongst the different businesses. What businesses were doing is they were finding a common database that they would have their whole company and organization use. And GE was no different, except we decided to go into a data warehouse. So when portals came on the scene, it was developed, and going into production, it was using the data warehouse. And initially, everything worked fine. No performance issues, everything was working according to plan. But then as we started to increase the amount of data we were putting into the traditional data warehouse, we started to see some bottlenecking and some performance degradation. Now, in this situation, what would you do? Well, typically you would increase or scale out, right? Well, with the data warehouse, it's not that simple because it's very monolithic. So with the data warehouse, what you have to do is you have to acquire more hardware, and a lot of that is proprietary. You also have to acquire more licenses. All of that is not cheap. And most notably, our group did not own the technology. How it works at GE is, well, especially during that time period, there was a centralized group that was in charge of all of infrastructure. That means they were also in charge of the data warehouse. So we were not in control of the data warehouse. We were not in control of upgrades or any of that sort. Then in 2011, and then early 2012, GE as a whole was undergoing a transformation. We were looking at different strategies, and we wanted to get out of the data warehouse game, in particular with on-prem. So we started to look at cloud technologies to see if that was a viable option. So to do that, they had each of the GE businesses do POCs. We're talking GE Aviation, oil and gas, energy, and a few of the other businesses. What they ended up doing is migrating 5 applications to AWS. And they wanted our feedback on what our thoughts were. Well, all of us thought there was so much benefit from that. Scalability, flexibility, we actually own the landing zone, things like that. So in 2011, 2012, GE made the decision to go all into cloud, in particular with AWS. And that is how we ended up on Cassandra. Earlier, Corey mentioned we were afraid of vendor lock-in. So we started looking at cloud-agnostic tools. Cassandra fitted that bill. So what we did is we ended up buying licenses from a third-party vendor. For those of you not familiar with Cassandra, Cassandra is an open source NoSQL database. We opted to pay for licensing because with portals, we can't afford an outage. Our customers are heavily reliant on that. So if something goes down or something goes wrong, we can call those vendors and have them help us get everything back up and running. Furthermore, because we're so new to the cloud space, we needed help architecting it in the cloud. So that third-party vendor gave us some architects, and if you look to your right, that is what we initially started off with. So we have 8 nodes, and each of those nodes have their own 8 terabyte EBS volume. Now with that, we also needed something to manage the cluster. That's why we have Ops Center. So by switching to Cassandra, we saw a huge improvement in terms of flexibility and also scalable performance. We also saw a lot more faster reads and writes compared to the data warehouse. But most importantly, we had our own autonomy. This is the first time in GE that a group could actually own their own technology and actually have a say in their own destiny. So we owned Cassandra, and then we also owned the landing zone, being our AWS VPC. And that's very powerful. However, with great power also comes great responsibility, right? When we switched to Cassandra, it's pretty much the same story as the data warehouse. What we have is we initially saw no performance issues. And then when we started to scale or started to increase the amount of data we were putting into the data warehouse, into Cassandra, we started seeing performance degradation. One of the main issues we were seeing is hotspotting. For those of you not familiar with it, what that means is when we're ingesting data, our writes can't keep up with it. And when we were ingesting it, we were writing to 3 different spots. So to help with that, we had to scale out. So on our initial slide, I showed you 8. We're now scaled out to 30. Each of those nodes has their own 8 terabyte EBS volume. So 30 nodes and 30 EBS volumes. That gets pricey very fast. Another key thing to note is I mentioned we were writing to 3 nodes. That's for data replication. Cassandra doesn't do that for you. So you have to do that. So we had 40 terabytes of data, and then you have to times that by 3 for data replication. And then on top of that, you have to have additional storage space for writes. So we're talking 40 times 6, which is 240 terabytes of data. That is very expensive. We also saw an issue with high overhead. With Cassandra, an example of this is with the hotspotting. We had to increase our cluster. When you increase your cluster and add nodes, you have to replicate that data. You have to move it around and repartition it. Cassandra doesn't do that for you. You need a skilled DBA to do that. Another key thing to note with Cassandra is you see all those individual instances up there. The top of the slide, you see the 30 instances. Initially, when we bought into Cassandra, we thought it would do backups. It didn't. So we had to acquire a third-party tool, Talina. That's 7 instances. And then we had to scale out Ops Center to 3. So all of those are individual EC2 instances you have to maintain. In total on that slide, there's 40 instances. So who wants to maintain those? No one. So with the data warehouse, we didn't have to worry about maintenance. Another group took care of that. This is the first time we have to take care of that. So now we need operations people to maintain that environment. And that's not fun. Another issue we saw was query latency. With query latency, what we were seeing is the queries were working fast for the latest data. However, if you had historical data, it wasn't that fast because the way Cassandra works is you have the latest data, then you have your historical data. To get to the historical data, it would have to scan through all of it. So depending on how much data you have, again, we have 40 terabytes, it could virtually take forever to get there. One of the key issues we saw was we always had to be architected for max volume. Initially, we thought Cassandra had the flexibility and the scalability for us. But because we're dealing with flight data, we can't anticipate how much data we're going to get from our customers. So we could easily get a couple megabytes. We could also get a couple terabytes. But because we can't assume or we know for a fact how much data we're going to get, we constantly have to be at max scale. So the price is always constant, and we can never decrease. So after dealing with some of these issues for a while, the team raised the question. We know initially we were afraid of vendor lock-in, which is why we went to Cassandra, which was cloud agnostic. But we've been with AWS for the last 4 years. One of the main fears being, were they going to raise the prices on us? They hadn't over the last 4 years. So why are we concerned about that now? And then also, AWS is constantly innovating new services. And with those new services, most of the time they take care of maintenance and all those other things for us. So why aren't we looking at some of those native services? So they did a quick POC with DynamoDB, and it alleviated a lot of the issues we saw here. So they raised the flag and went to leadership and told them, hey, we want to switch to DynamoDB. And leadership told them, go ahead. With DynamoDB, we instantly saw performance improvement. The key thing with DynamoDB is it automatically scales for us. We don't have to worry about anything. What I want you to do is look at the two charts we have. Off to the right, we have two charts, read and write. Numbers don't matter for this one. What I want you to focus on are the colors. Blue is consumed, red is provisioned. And if you look at the charts, you'll see that consumed rarely ever goes above provisioned. But you can see it's constantly flexing up and down, up and down, up and down. And we're rarely ever going above the provisioned. You see, with Cassandra, we were always maxed out. It's always constant. So imagine that red line. For Cassandra, it would have been, let's say, I think 150, for example. It would have been like that across the whole chart. Here, there's variability. And that's key, especially with costing. But what's nice to note here is with the auto scaling, it's constantly going up and down, which means it's scaling in, scaling out, scaling in, scaling out. So that's really giving us the flexibility that we need. And most notably, as it's doing all of that, it's repartitioning the data for us. So DynamoDB is a PaaS solution. And so when we switched over, it showed us a lot less maintenance. With the maintenance, earlier with Cassandra, we had a DBA dedicated to the cluster. With DynamoDB, we maybe need a DBA a fourth of the time, maybe less than that. We also no longer have to worry about compliance issues, because to us, we're only interacting with DynamoDB. Maybe DynamoDB sits on top of EC2 instances. Do we really care? I don't. Because at the end of the day, all I know is AWS is taking care of the patching for me. I don't have to worry about it. So the key thing to note here is because all of the maintenance is being taken care of for us, we are able to take those resources and repurpose them into other projects that will have value add for our customers within the portal space. And lastly, DynamoDB also gave us a lot smaller footprint in our environment. So to the left is our Cassandra footprint in our environment, and to the right is our DynamoDB. I'll summarize on this slide. Cassandra, in total, had 40 nodes in its environment, 30 in the cluster, 30 EBS volumes, each being 8 terabytes. We also had our Telina backup, which was 7 nodes, and then we also had Ops Center, which was 3 nodes. All of that for our team was pretty much a maintenance nightmare. A lot of folks had to put in a lot of hours making sure everything was maintained, staying in front of security issues or vulnerabilities, things of that nature. With DynamoDB, we were able to substitute 40 instances with 5 DynamoDB tables. To me, the DynamoDB solution is a lot more elegant and streamlined. One key thing to note is with the Cassandra cluster, again, we had to be in charge of the backups. By using the PaaS solution of DynamoDB, you can go through the console and you can say, hey, I want you to back up this table. Click a button. Our team did not want to do that. We wanted to automate as much as possible. So what we ended up doing is using a CloudWatch cron, and that will run once a day, and it will trigger a Lambda function. And then that would take care of the backup for the table. One key thing to note with DynamoDB is because it's cloud native, it is basically plug and play in terms of the other services that AWS provides. And that is key, because that will open up the possibility of using this for other projects or other applications that Portals inherits in the future. It also helps in terms of automation. And I'll leave you with this last example. With Cassandra, we had data validation. And data validation is very important because we're dealing with flight data and time series. If the data is wrong, the stuff has to be reprocessed. That validation process had a whole team dedicated to it, and it would take 1 day. So imagine yourselves coming in to work every day, do the same job day in and day out, manually checking this data, making sure it's correct. By switching to DynamoDB, we were able to automate that whole process. We took it from 1 day in Cassandra to running 12 times in a day, and each time it runs for 3 minutes. We're able to take that whole team and repurpose them for other projects that will add more value for Portals. And with that, I'll go ahead and pass it back on to Corey.
All right. So thanks, Ari, for taking us through the architecture. Just to kind of review the architecture, the key thing for us was we're now at a super scalable level with a large amount of data. Now, being our first foray into these native services, we didn't know what to expect, to be honest. Like, we hadn't worked with them directly. We hadn't worked at this level of scalability before. So now we're trying to figure out what's next for us when you look at this. You know, from a workload scalability, we don't even worry about it anymore. It just happens on the back end. We've done some work to make it scalable in that there are some limitations in how you scale up and down. But you know, that's feedback we've given to AWS as well. Our storage is ultra scalable too. It'll grow to whatever we need. We only pay for the storage we're using. They take care of all of the necessary replication on the back end to manage it for us. The maintenance overhead is a huge amount of capacity on a team. If you have a team that basically is dedicated to patching, to OS upgrades, to the variety of tasks that happen just to make a cluster run on a day-to-day basis and keep your compliance and risk department happy, it's a lot of work. It's not necessarily value add when you think about yourself as a customer sitting in the seat. Sure, you want all of our stuff to be secure and you don't want that data going anywhere, but you'd rather just get to Las Vegas on time. I mean, that's probably your primary goal at that point, and that's our airline's goal at that point too. Help me get this plane to Las Vegas and not be delayed. So as you look at the data that Ari talked to you about on the right, there's 5 tables there. Those 5 tables are used for us to tell a story. There's one large table that is all time series. There's a flight report table, which basically connects all the dots of all that time series into basically replaying a flight. What happened on a flight? Replay it for me. So Beyond that, you have a bunch of master tables. So there's only one table there that's huge. The rest are essentially connecting dots between all the rest of the data to tell that story. The ability to create that same in Cassandra was very, very difficult for us because there's a limitation on indexing in Cassandra. There's a limitation on how you pull that data together. We learned a lot from Cassandra. We probably would have done it differently had we done it again. But foraying that into Dynamo allowed us a lot of flexibility in how we work with this data to set us up for the future. So what were our outcomes? We see approximately 11 to 16 millisecond response time on all of our queries, which were before ranging largely depending on the data that we were retrieving. So depending on what the cluster was doing at the moment, if the Cassandra cluster was ingesting a large amount of flight report data at one time, those reads would slow down. We don't see that same slowdown when we're ingesting into Dynamo. If there were a large amount of data queries going on at one time where it was pulling a ton of data out of the cluster, you'd see those returns on the reads slow down as well. We don't see that. We see the Dynamo scales up, meets the need. We've only seen a couple times where it's gone beyond and been throttled. We don't see those issues in Dynamo at all, and we did see them frequently in Cassandra. We were able to deliver code improvements through Dynamo at the same time. We were able to kind of manage some other things we found along the way. By using the services and rethinking our process, we were also able to do code differently. It's kind of a thought process change that our developers have started to overcome is, how do I take what I'm used to doing, which is writing large Java programs, and turn it into more of a small function-based kind of approach? That's a hurdle that the team had to overcome in this process. But they're starting to get there. It's a very different way of thinking for them. Not only that, but we built a huge backlog of continuing improvements, all based on Amazon services. One of them is Athena. We have all this data. It's all currently live in Dynamo. For the functions that we use in plotting, which is where we need the live data response, we probably only need 6 months to 2 years there, depending on who you ask, and that's a question for our business to answer. We could put the rest of this data into S3 and use use Athena against it as an option. So it's kind of opened our eyes to a whole bunch of different services we hadn't thought about. The other part is how we load the data. We traditionally have relied on ETL-type processes to load this data just historically from within GE Aviation. Now we're looking at Kinesis as a better way to probably load this data. There's a lot of complexity in how this data comes to us. Some of it's actually emailed to us, which creates a whole lot of parsing confusion in how we get this data into the system. But we think we can handle that better with Kinesis rather than more of a monolithic ETL approach. So these are things that now that we're in Dynamo, now that we've looked beyond the cloud-agnostic front, we're looking at data services. Cloud services. We're looking at services that allow us to expand beyond just Dynamo. So for the team, it was a very eye-opening experience to go through this. So now I'm going to go to the fun slide, which is the cost. This is a bit of an eye chart from in the back, I'm sure. But let me walk you through that. What we did at the beginning of the year was essentially we diagrammed out, given how we were scaling with Cassandra, where would we be at the end of the year? What would the 100% line be? What is that daily run rate? And we started thinking about daily because with Dynamo, we're going to scale up and down every single day in a way that's going to be a much more variable cost. And we wanted to understand on a daily basis what that would look like. Now with Cassandra, we were scaled for peak capacity because we kind of had to know when we would have a huge number of flight reports come in, scale for that, what we had seen, and be ready to handle that so that we could still do reads on the same cluster as we were ingesting data. The trick to that is that the freshest data is also the data that gets queried right away. So as soon as you ingest it, they're trying to query it right away. So you're creating this dilemma where I'm trying to ingest it as fast as I can and also read it at the same time, which was creating some bottlenecks in Cassandra as well. So we had to scale up for peak. We had to take into account overhead for backups and DBAs and other things that were additional costs or additional capacity we had to have. We had to patch these things. We had to keep the OS up to date. We had to keep all of the pieces running at a level that our compliance and risk team would be happy with. We also had to have licenses for Cassandra, the vendor that we chose, as well as Telena for backup. We had to have those in-house too. So you end up with this flat line that is essentially Cassandra. Now you can see at one point that yellow bar goes up again because we ended up at a point where we had to scale just to meet the demand before we got Dynamo done. But essentially the yellow line, by the end of 2018, all things held static, we would have been at 100% with that yellow line. Now the migration is an expensive piece of this project. You have to get all that data to Dynamo. You have to have write capacity to load, in our case, 40 terabytes of data into Dynamo. Now, in addition to that, you're going to have to build indexes, which also cost you data storage. You're going to have to use all these processes to ingest, and we were ingesting at a significant rate. I think we bumped our ingestion rate, our write capacity rate, up to 500,000 units to get through this process. That's pretty expensive when you look at the overall cost of the project. There were 6 ETL EC2 servers to running basically 24/7 to load this data. It created some knowledge about Cassandra that we didn't understand. Like Ari mentioned that the historical data took a lot longer. We were bringing our Cassandra cluster down just trying to read the data from it to get the data written into Dynamo. Dynamo was writing it as fast as we could get it to it. Cassandra couldn't keep up with the reads. So we had to build that ingestion process. We had to ingest at max write capacity. So we spent a lot of money in the middle to migrate. But when you look at the green line at the completion rate, which this project is complete, it has been completely live for about a month now, we're down 72% over our 100% line for what we see as ongoing costs with Cassandra. That's a significant amount of capacity to use to meet the needs of our customers, to build further functionality, to add to the level of functionality that we have within our sites for our customers. The next step is how do we vision this in the future? I don't think any of us really kind of went into this expecting this kind of success with it, but the 72% is pretty significant for us as we look to the other tools. All of our internal tools need to use some set of data. At this cost, it's hard not to think about the possibility of reducing this even further with other things around Athena and S3 based on what we've learned. You know, there's a lot of options here that we hadn't considered from a native perspective when we were all in on cloud agnostic. And I think those learnings kind of come true in this chart, because if I kept my budget the same, I now have a huge amount to invest on other projects, on other services, on other pieces that make the customer experience better. The key, though, is all of this is scalable. If we need to spike up, if we continue to see the Leap engine go into service and you have a huge ingestion of data, we're ready to go. We're ready for whatever we need to do here. And that allows us to not invest more time in re-architecting and allows us to grow with a set of services that meet the need of all of our customers. So it's not perfect. There's a few things that we had to think about in this process. Our customers, not our customers, our internal folks in our fleet support team are very used to Oracle. They're very used to, they had even learned how to write queries in Cassandra, and they had learned how to get connectivity to Cassandra directly to write queries. We haven't allowed that in Dynamo. It's created some change of behavior within our business. We think with Athena we can handle this, and I don't know, not everybody probably has this problem, but we haven't let anybody access Dynamo directly for a variety of reasons. And it's creating some churn within the business. But I think it's an important factor to think about as you move to more of the native services, especially within the data space. If you have a situation where people are just used to kind of self-serving their data through direct SQL queries, Dynamo is going to be a change of pace for them. You're going to have to think about how you address that. And we still have ideas that we're working on to make their lives better. As we go to a single version of this data, which is our goal over time, those other data sources that are still out there are going to fall away. We're going to have to handle this. But it's a mindset change for not just for us, for our developers, but also for our business. The auto-scaling within Dynamo is fantastic, but we had to do some knowledge, some tricks to figure it out a little bit. Largely, you can scale up as much as you want. They don't mind you paying more for it. But when you want to scale down, there's a limitation on the number of times in a period of time that you can scale back down. So it's not like you can follow your demand curve exactly. There's always an up, if you remember the graph, and then it kind of goes out, and then it comes down. We've had to kind of work and figure out how to scale that up and down. It wasn't quite as intuitive as we thought going into it. It required a little bit of scripting work for the team to kind of work their way through it and understand. There were a few weekends I remember where one of the team members left everything at the max, so we paid a little bit for that. So there's kind of some care and feeding you have to do to it to make sure that you're not always paying for the max, especially in the dev environment. The data loading in any project, as you probably, if you've ever migrated between platforms, know is a significant amount of the work. Kind of go in knowing that. We didn't find a lot of tools that allowed us to migrate directly from one to the other, largely because we were changing our data partition scheme between Cassandra and Dynamo. And so when you do that, now you're kind of transforming the data in the process. You're having to re-ingest it in a slightly different format than what you pulled it out. So if you're going straight in, it might be much more smooth for you. But I would take advantage of some of the things that Dynamo offers from a global secondary index perspective that really were a little more clunky in Cassandra in the process, which means you're going to have to do some of this data manipulation along the way, which is going to add to your time and cost for the migration project. Backup and point-in-time recovery. These were things that were key to us, and this kind of segues into the last point around moving fast. When we started this project, they didn't have it. They didn't have it available for Dynamo. They also didn't have encryption at rest available at that time. But we were talking to AWS the whole way. They had it on their roadmap, and within a couple months of us starting the project, they had it available for us. And so what we learned is that the more we raise our voices, the more we ask for these kind of features that are basic, it seems like they're responding pretty quickly, and we were extremely happy with that in the process. Given that we have aviation data, there's a lot of sensitivity around this data. So these were very important things for us to even kick off, to have that trust in AWS, to know that by the time we got to the project, that those things would be there, was extremely important to us along the way. But I think the biggest lesson we learned is that it's okay to go native cloud. We hadn't really forayed into it very deeply, but as we kind of look at our EC2 chef background, which got us down the road, the native services have allowed us to think differently about how we developed. It has allowed us to think in smaller bits, to smaller services, to better flexibility as we go down the path, the ability to do things that really we hadn't thought about because it would require a huge development team. Now you can bit and bite things out a little bit differently in the way you develop, the way you use these services. We don't need a DBA on our project for the whole period of the project now. We have this data there. It's pretty easy to take one DBA and spread them across multiple projects. As a simple example, it's not to put down any DBAs. That's not the goal here. But it allows them to also get into the development process. We had that experience in our project, and it's opened their eyes to different technologies as well. And it's been a really good journey for the entire team in this. In that now every project we take on, we're thinking about differently. Thinking in smaller services, we're thinking about using cloud native first, and then going to EC2 if we have to. And that's pretty serious at this point within the team, and it's going to allow us to go faster in the future. So with that, we'll answer some questions if anybody has questions. We have 15 minutes left, so please make the questions easy. and I'll make Ari get up here.
Hello.
Hey.
I'm curious to know what mechanism you use to transmit the engine performance data. You said they're on the engines or in the engines. Sometimes you transmit it during flight, So I'm curious, do you just tap into the airplane's Wi-Fi, or are you talking directly to a satellite network?
It depends on the airline. It depends on the different situation. It depends on the country. Each operator kind of has their own process, and there's ACARs, there's different satellite technologies. Sometimes it's a field support engineer plugging in something, downloading it off of the flight computer. So most of this data comes off of the actual telemetry in the airframe, which is not the engine. So the engine sends it to the airframe. It's all stored on the airframe and then pulled off that way. So manufacturers can vary. Operators can vary. It's a very different process for each one, depending on the age of the plane and where they're flying. So unfortunately, there's not one, which makes our process really complex.
Sure, understood. Thank you.
Yeah, Yeah, so for those that in the back that didn't hear that, the question was, most of the data is more data warehouse in nature. It's more of a write once, read many situation. And why not use Redshift versus Dynamo? The answer to that is there's actually multiple writes in that process because there are errors that happen in the data. So not errors in the actual sensor readings, but rather if you think about the life cycle of an engine, it will come off of a wing, go on another wing, come off a wing, go on another wing. They move around a lot more than you think. They don't stay on that wing forever. And so what happens is the data keeping for which tail or which fuselage that wing is attached to changes way more than people think. Also, the owner of engines changes. So in the case of a spare, so what we do in many contracts is provide spare engines. The operator, a spare engine will probably go to 10 operators. I don't know the actual answer, but it's a lot of different operators. So it may have transitioned between operators. And so now you find out, wait, that engine wasn't on that plane for that flight, it was on this plane. So now you basically have to drop all that data and start over with those flight reports and reprocess them, which creates a situation where you have to go and find that data and essentially delete it and re-add it, which creates more of a write a few times as opposed to just a write once. I think if it was a write once, it'd probably be a more appropriate solution, but this fit what we were looking for from our performance and write perspective. We got somebody at the microphone, sorry. You go first. Go ahead.
So for NoSQL design, row key design is super important for especially predetermining your access patterns.
Yep.
You mentioned that you redesigned some of your row key or your models. How much do you think was that a factor on the cost reduction compared to just moving directly to Dynamo? Like if you would have done that same model in Cassandra, how much do you think would that have saved you?
I don't know that we could have designed the row key pattern in a way that would have spread the data in a way that we weren't still hot spotting instances the way our flight reports come in. That was a key issue that we found in Cassandra, is that we contracted with someone, with experts on this situation, and we went through about 5 designs trying to figure out how to get the data partition right, and all of them ended up with the same problem at the end. And then if we wanted to expand that cluster, we'd have to repartition all the data, which in Cassandra takes quite a while to get repartitioned. It was just creating a lot of overhead. So I think the biggest case for cost reduction was essentially EC2 instances that went away. In that when you take 40 4XLs, M4 4XLs and kind of add them up, it's a lot of processing power that we didn't really have to have on the ready at all the time. And so now we're just using that, essentially the same horsepower when we need it, as opposed to having it available 100% of the time. Sorry, go ahead.
How did Dynamo help you with historical data?
So Steve probably knows this answer a little bit better than me. I'm not going to point him out, but he's right there. You can ask him afterwards, but he can talk more, but we haven't seen the same historical lag that we did in Cassandra because of the way Cassandra was scanning. That's about the depth that I can go. Steve can go deeper, though. He was a DBA. Sorry, go ahead.
I was curious how complex the schema was in Cassandra versus going to 5 tables in Dynamo.
I don't think the schema was horrifically different, as much as we found some errors that were creating duplicates in our process. And so what we did essentially was change the key to prevent those duplicates in the future. The reprocessing that I described earlier, that was creating a lot of issues in Cassandra because the eventual consistency of reprocessing came in before you could really get to all that data again. You'd still leave all this data hanging out there that you didn't really want. That was a large consideration for the data partition and how we handled it.
Okay, thank you.
Over here. Sorry, I didn't see you guys over there.
Can you touch up on your multi-tenancy within the 5 tables?
I'm sorry, say that again?
Multi-tenancy, multiple customers. You sounded like you do have like 60,000 different customers, if I understood this properly. Multi-tenancy, how do you differentiate between the customers within the data?
So the security on the data is something that we didn't touch in this process. We're still using the same security model in how these services access the data. So since most of this is considered internal data, we keep it all in one database. We haven't gone multi-tenancy on it because of the way our old security model was. If we change that security model, we might open that Pandora's box. But we haven't touched that yet, just based on how our security model has been pushed forward from where we were previously.
The other topic you mentioned was the CloudWatch versus streams now. Would you still use the CloudWatch to do the backups, or would you use the streams on Lambda?
That's something that I think Steve could answer at depth, but we've debated that. I know he debated that with the team over and over. I don't remember his considerations. He'll catch up with you, too. It's good thing Steve's here. Wait for him afterwards. You can attack him. Over here?
So earlier in your talk, you had mentioned some historical data, like 20 years worth of engine data. And later in the talk, you briefly mentioned global secondary indexes. So I was hoping you could connect the dots. Now that you're using Dynamo, if you want to access 20 years of historical data, what can you tell me as far as what kind of indexes you are using and how those have benefited you?
So that's probably another question for Steve, but I can touch on it briefly. I'm just throwing stuff at Steve for the hell of it, so sorry. No, the global index issue is when we put the data in Cassandra, we had one use case in mind. As everybody knows, as soon as you put data in a database, the business will think of another use for the same data in a different way. We've been able to handle those use cases, so the access for data query versus plotting is a little bit different. The key in Cassandra was kind of cobbled together in a way to do both. We're able to use indexes a little bit more efficiently in Dynamo to be able to handle multiple use cases in a way that we hadn't been able to do in Cassandra very easily.
All right, thanks.
Yeah, I saw the graph involves the EMR. So could you elaborate a little bit more? Because I also see that for Dynamo, normally it's like a single row access, much better. But it seems your query access pattern also involves batch and large set of data. So how do you use EMR to kind of solve this kind of problem?
So EMR was an approach to do data validation across other data sets that we have in the business. So it allowed us to aggregate data from multiple places, as opposed to just Dynamo. So now we could use the multiple pieces, validate them in one tool versus having scripts in various places that we're doing it previously. So the EMR largely exists just for that data access and kind of the admin function of validating the data across not just Dynamo, but the other instances of that data that we still have in the business that we're trying to migrate away from.
So mostly when you access your data, you just rely on some of those global secondary index to get all your query needs. It seems, is that because your query access pattern is limited? I mean, the way people ask for questions is like based on engine, based on time. So it's not so elaborate that you need a traditional database or RDS type of, or Redshift even.
Right. So if you look at the migration to this was data for a very specific purpose around plotting and data query. The thought process forward into kind of S3 and Athena is to handle some of that other data access that, now that we understand how these services work within AWS, opened our eyes. Because Cassandra existed essentially just for this exact service of getting plotting data, of getting the data query data out. It didn't exist for any other reason. And so now we have the ability to think, which has opened our eyes to other services that we hadn't really considered other than Dynamo in this case.
Yeah, that confirms my
Yeah,
view.
it was very specific. Thanks.
Have you guys reserved any of your base capacity in that graph where you had the cost?
Not yet.
Okay.
That's
even
something
lower.
that, it's a little bit complicated in GE because GE Corporate owns all the AWS contract. And so if we were doing it for ourselves, we would probably go base capacity at reserve. But it's a conversation we're trying to start right now because we want to understand that delta in cost as well.
Thanks.
We needed a little knowledge before we did that, though.
Hi, you might already answer this question, but I'm just wondering about the nature of the data. Is it very relational, or I think maybe you pointed out it's for a specific use case and it's just built that way. So, it's simplistic in a sense from a relational standpoint, and that's why Dynamo is a good fit for it?
Yes, it's mostly time series off the engine. The other tables that we put into Dynamo are just to connect the dots with that large time series data set. They involved connecting a flight report to an ESN, to a customer, to a tail number, that sort of relationship that we have to establish somewhere. Okay. The raw data that goes into the parameter data, the sensor data, we wanted to keep as original as possible in the data set because of the reprocessing process that has to then come and fix it. It was easier to do it that way.
Thank you.
I don't know. Dynamo provided it. I don't know the answer to that. Steve, do you know the answer to that? Oh, in transit? Okay. Only at rest, not in transit. Sorry. You were asking in transit or at rest? Yeah. Yeah. This is default for the VPC. All right, any other questions? All right, thanks everyone. Have a great rest of the day.